Quicksort algorithm. It's an algorithm to sort an array of numbers. So when do we say an array of numbers is a sorted array? We say it's a sorted array when every number in that array is in its correct position. So when is an element in its correct position? We say an element is in its correct position if every number which appears to the left of that element is less than that element, and every number which appears to the right of that element is greater than that element. If this condition applies to every element in the array, we say that the array has been sorted. With this idea in mind, let's look at what quicksort does with a sample array. So I've written down the elements of the array. Now I'm writing down the indexes. So the first step of quicksort is to choose any element from the array and call it the pivot. For convenience sake, I'm going to always choose the pivot as the last element of the array. So in this case, I am going to choose 4, which is the last element of my array, as the pivot. Next, what we'll do is we're going to rearrange the array in such a way that 4 comes into its correct position. What does that mean? All elements which are less than 4 should come to its left, and all elements greater than 4 to its right. So let's see. 1, 3, 2. These are the elements less than 4. So these are going to come to the left. Now we have 7, 5 and 6. These are the elements which are greater than 4. So they'll come to the right. Again, I am writing down the indexes. So now, as you can see, we've chosen a pivot and we have put the pivot in the correct position. This process is known as partition. Upon doing partition, what do we get? We get a left subarray, which is 1, 3 and 2, consisting of elements less than the pivot, and a right subarray, which is 7, 5 and 6, consisting of elements which are greater than the pivot. We also get to know the correct position of the pivot, or the pivot index. So here we have the left of 4, and here we have the right of 4. Now 4 has arrived at its correct position. If we can ensure this for every element of the array, we can say that the entire array has been sorted. So we need to apply this partition algorithm again and again till all the elements of the array have come to their proper position. So let's first apply the partition to the left of 4. When we're applying the partition to the left of 4, the pivot chosen here will become 2, since 2 is the last element of the left of 4 array. On applying the partition algorithm to just the left of 4, all elements which are less than 2 will appear to its left, and those elements which are to the right of 2 will be greater than 2. So within this left of 4 array, 1 which is less than 2 will appear to its left. We will have the pivot which is 2 itself, and we will have 3 which is greater than 2 to its right. Now we will have 4 and the right of 4 array to which the partition algorithm has not yet been performed. Once again, what do we have here? Let me write down the indexes. If you remember, the partition algorithm gives us a pivot index, a left of the pivot, and the right of the pivot. So over here, we are going to get a sub-array which is the left of 2, and we are going to get a sub-array which is the right of 2. This entire array is the left of 4. And this array remains the right of 4. So now 2 has come to its correct position. We need to see the left of 2. Let's apply the partition algorithm to the left of 2. Now, the partition algorithm for the left of 2 will choose 1 as its pivot. There is no more elements to push to the left or to the right of 1. So we can say that 1 is in its correct position. Since 1, a single element array, is always in its correct position, we say that that single element array is a sorted array. So we have found out that the left of 2, a single element array of 1, is a sorted array. So now we have to apply the partition algorithm to the right of 2. A single element array consisting of 3, once again using the same logic, is a sorted array. So we know that the left of 2 is a sorted array and the right of 2 is a sorted array, which means the elements of the left of 2 are in the correct position, the elements of the right of 2 are in the correct position. We also know that 2 has arrived in its correct position. So we can say that every element in the left of 4 has been placed in its correct position, or we can say that the left of 4 is a sorted array. Once we know that the left of 4 is a sorted array, we must apply the partition algorithm to the right of 4. When we apply the partition algorithm to the right of 4, we will choose the last element of the right of 4 as the pivot. So over here, the pivot is going to be chosen as 6. Since 6 has been chosen as the pivot, those elements which are less than that, that is 5, are going to go to the left of 6. And those elements which are greater than 6, which is 7, are going to go to the right of 6. Once again, I am writing the indexes. Over here, we have the left of 4 which is known as a sorted array, as we have just seen. Then we have the left of 6, and we have the right of 6. This entire array comes under the right of 4. So 6 has been placed in its correct position. Now we must apply the partition algorithm to the left of 6. The left of 6 is a single element array of element 5. And hence, since there is no elements to be pushed to the left or the right of 5, we say 5 is in its correct position, and 5, a single element array, is a sorted array. All elements in the left of 6 are in its correct position. 6 itself is in its correct position. Now we must look at the partition algorithm for the right of 6. 7, a single element array, is already sorted using the same logic, and hence, since every element in the left of 6 and every element in the right of 6 are in its correct position, and 6 itself is in its correct position, we say that every element in the right of 4 is in its correct position. That is, the right of 4 is a sorted array. Let's see what our array looks like now. We have already stated that the left of 4 has been sorted, and we have just found out that the right of 4 has been sorted as well. That means every element in the left of 4 in its correct position. Every element to the right of 4 is in its correct position. 4 itself is in its correct position. Therefore, every element in the array is in its correct position. Therefore, we can say that the entire array is a sorted array. This is how quicksort works.